Welcome back everybody. Today I gonna start with cost function, and in today's class please remember to watch till the end as it is very crucial topic. So I will suggest do not miss a single second of it as it will be used multiple times in the further videos and the classes and also in the projects. So let's get started. So before we continue, do not forget to subscribe our channel and press the bell icon so that you get the further notifications of our channel. And thanks for your support by giving a huge views and sharing with others. And please kindly like this video, and please, if you haven't watched these videos from starting, then this is the playlist machine learning where I have taught from starting. So you can go there and watch from there. So let's continue. So what is a cost function? Actually, it is a function we use to calculate the minimum value of j of theta 0 and theta 1. So let's move further on and see how this works practically. So let's see, this is a training set. So this is from previous video about some reviews. So this is our training set with wait a minute. So this is the size in feet. Wait a minute, what just happened? Oh, so this is our size in feet square, and this is the price for specific value. So this is our input, I will represent by I, and this is our output. And the function we use here, you know better, it is the hypothesis function. So it is h subscript theta x is equals to theta 0 plus theta 1 x. So thetas are the parameters here. So now let's talk about how to choose theta. So this will be very important, and I will talk it at the end of the video. So let's move further on. So let's plot examples. So how do we plot examples? So let's do how we plot our examples. So here theta 0, wait a minute, yes, actually, okay. So theta 0 is 0.5 and theta 1 is x. So as you see in the previous slide that h of theta x equals to theta 0 plus theta 1 x. So here let's say our theta 0 is 0.5. So let's take it as a linear function, so our x will gradually increase. So let's take it x is equals to 1. So when x equals to 1, theta 1 is only 1 and it is 0.5. So our output will be almost 1 point, exactly 1.5. So it will be somewhat here and our x is here. So this will be like this. So this point comes, but graph for different values of theta 0 and theta 1. So when we plot, we take x theta 0 from here, and then it will be a gradually straight line like this. Here this point will be covered, so it is not exactly straight, but this will be a straight line only passing through point 5. So this will be, as we can also see like it, we take x wait a minute, what happened, x equals to 0, then this will be only 0.5. So this is the plotting for this. So let me just erase this to make it look little bit good. So now you have seen this. Now let's move on further on with the example little bit like this. So now our theta 0 is 0.5 but theta 1 is 0. So this means that when it will not matter that we change x or not here in this example, because theta 1 is 0, so this term will be ultimately 0. So this will be theta 0, and the output will be same for all the values of x, and here theta 0 is 0, so this will from center towards like this. So these are the plotting examples. I hope you all have understood it better. This will be a just wait a minute, it will be more straight. Okay, like this. So now it's good. So this is from the previous class. We have looked about this function and this hypothesis function. So let's move on. It is of course will be used in this video, so do not think that I am just wasting your time. This will be used. Let's move on. So wait a minute, just here, that's okay. So this is our cost function, which we will be used to minimize our j of theta 0 and theta 1. So we can measure the accuracy of our hypothesis function by using a cost function. We also use this for measuring the accuracy of our hypothesis function. This takes an average difference, actually a fancier version of an average. This will be lot of fancy than the average, and of all the results of hypothesis with inputs from x and the outputs y. So I have told earlier also, x represents input and y represents the output. So here in this, the formula is 1 over 2m sigma. This is called sigma. If you are not much familiar with the maths, then this is used to sum all the quantities which we will get, and this is the m for m training examples. Total training examples are these. Training training examples. So these are total training example. So these are the total training examples, and this is the starting number when I equals to 1, which means that this will take the first input, then the second one, then the third one, till x approaches m. This will be the mth input. Wait a minute, sorry. And same here, for corresponding x1 there will be corresponding y1, y2, the second output, and this will also continue till ym. So this will be from I equals to 1 to I equals to m. Then to break it apart, let's see the x bar, 1 upon 2 x bar. This will be where x bar is the mean of squares of this. So this means that 1 over 2, this we call it, let me write it, h of x minus y. I have put I equals to 1 here. Then this will represents the x bar. This is the mean of this. So mean of this. Wait a minute, let me just clear this. So this is the mean of this quantity. So now next, the difference between the predicted value and the actual value. Here the h theta x is the predicted value, and the y is the actual value, So this function is otherwise, it is also called the square error function or mean square error. The mean is half as a convenience for the computation of gradient descent. This is for convenience, as the derivation term of the square function will cancel out. So if you are not much familiar with the derivative, then I will tell you just simply that whenever we will derivate this thing, the 2 will come here and will cancel out the half, and this will also have, wait a minute, let me just first clear this so that I can use this easily. So let me just clear them all. I will recommend you to just take notes before I erase, and if I have erased it before you have taken notes, then I request you to please kindly go back and please take a screenshot of it so that you do not forget. So 1 over 2m, and its derivative will be multiply by 2 h of theta xi minus yi multiply by xi. So this will be the derivation, so half will cancel out this, so this will be the derivation of it. And as the derivative, this is we have done. The following image is summarized, the next image will be summarized this. So this is the cost function. So now let's see what I mean by the minimizing function. So let me just do it this. Okay, so this is a minimizing function. This will minimize the value of this whole as a whole. So here what happens is that here this let me just explain this too first of all, or let's see this only. So when we know what this means, this is the our h of theta hypothesis function, h of theta x, wait a minute, like this will be equals to theta 0 plus theta 1 x. So this will be, when we elaborate this will be written here. So we try different values of theta 0 and theta 1, or just differentiate it and we get the minimum value. So we also use it for minimizing as a minimizing function or square error function too, and we minimize it until we get the what we can say, that closest, the predicted value and the actual value comes the closest. That's our main motive, so that there will be minimum error or no error when we use our data for a particular machine learning algorithm, so that there will be minimum error. So let's move on. So the idea which I was talking about earlier was that we choose theta 0 and theta 1 as like that whenever we have to, so that our theta h hypothesis function is close to for our training examples. What I mean by that is h theta x have a closest value to y. Wait a minute, is close to y, sorry for, but this is the correction here. We want this to be as close as possible. So like here we want to check which straight line will be good. So this will be, wait a minute, just little bit. So this will be more good. So this will be a straight line we will use for this our function. So this will be the straight line of our function for hypothesis. So this will be used here when I, the image which I was talking about earlier, what the cost function does, it minimizes or it generates such a line which is, wait a minute, this getting a lot of mesh. So let's just clear this and like this. So this is not accurate, I know, but this will be kind of say little bit accurate. So what this does is it generate a hypothesis which it generates such a line by using the previous function this and minimizes the error, and we get to, so like say for this input we have this output, for this one we have this one, kind of this. Okay, so this is all, and this will help us to minimize the error and get us as close as the actual and the predicted values. So this is the mainly function of this coast function, to minimize gap between predicted, wait a minute, predicted value and actual value. So this is the main motive of our cost function only. So this is for today. Before you close this video, kindly do subscribe to my channel, and this is the link for my Instagram ID. You can follow me there. I daily post their videos like the one I post on YouTube. So where you like you can watch, and I post other videos too which help you exceed in your life. So that's all for today. Thank you for watching. See you next video.